Hi, this is Melissa Dias, and I wanted to talk a little bit about how to compare fractions so that you understand what the size and value of the fractions actually means. A lot of fifth graders come in with the idea that you can cross multiply or use the butterfly method, where you would multiply 3 times 3 and 4 times 2, and you figure out this is 9 and this is 8, so this one's bigger. But when you do that process, you kind of miss the meaning of what each of these numbers actually represents. So I want you to try and figure out how to compare fractions in any of these other ways first. So my number one way here is to just look at the number of pieces. Here I have 1/6 and here I have 5/6. Well, both pieces are the same size, so having 5 of them would mean that you have more than having just one of them. So when denominators are the same, you really only need to look at the numerator to determine which fraction is larger. In my number 2 example, we're going to look at the size of the pieces. I have 3/5 and 3/4. And I tell students that this is a chance for them to be greedy, something that you never hear about. But in each of these cases, you would get 3 pieces. So if you're sharing something like a pizza with 5 people and you get 3 pieces, those pieces have to be cut so that everybody would get an equal amount split 5 ways. Well, here, if you're sharing it 4 ways, you're going to have bigger pieces because there's less that you need to share with. So if numerators are the same, meaning the number of pieces you get is going to be equal, the less ways you have to share the whole means that these pieces on top are going to be larger. So practice thinking about when numerators are the same, be greedy, and think about how you're going to get more the less people that you have to split it with. The only time being greedy is okay. Another comparison that I like with fractions is thinking about the value of 1/2. We can usually figure out what the numerator would be if the fraction were equal to half. So here I have 1/4. I know that if this were 1/2, I had 4 pieces, half of them would be 2. So 2/4 would be the fraction that's equal to 1/2. Well, 1/4 is less than 2/4, so this fraction I know is going to be somewhere on a number line smaller than 1/2. This fraction's a little trickier because I have an odd denominator. So if I have 3 as my denominator, I'm not ever going to write a fraction numerator that's going to be a decimal or a half. Wouldn't have 1/2 over 3. But I can think about it that way. I can think that half of 3 is 1/2. So if I had 1/2 here, 2 is going to be larger than 1/2. So 2/3 on a number line would go larger than the halfway point. If it was 1/3, 1 is a little less than 1/2, so it would be on the smaller side of the 1/2 mark. Thinking of fractions this way just kind of gives you a broad picture of where to place them on a number line. In this case, I can compare these two fractions to each other just by thinking that this one is more than half and this one is less than half. Well, comparing them to half means this is more and this is less, so this fraction must be larger than this one. A fourth way to compare fractions is to think about what they would be if we change them to a percentage or a decimal. Percentages and decimals and fractions all represent a part of a whole. So if I have 2/3, I can think about having 2 out of 3 pieces. I can think about having 66 hundredths out of one whole, or I can think about it as 66% out of 100%. So if I start to recognize that 2/3 is equal to 66, I have that value in my head and it makes it pretty easy to compare. It's much easier when you're comparing whole numbers than when you're comparing fractions. 3/5 as a percentage is 60%. As a decimal, it's 6/10 or 60 hundredths. So if I'm comparing 3/5 to 2/3, and I think about it as 60% to 66%, well, it's pretty easy to see which one is larger. These fractions would be tricky because they're pretty close in size, both a little larger than 1/2, neither of them the same denominator or numerator. So thinking of another strategy is a way to help figure out larger and smaller. Another strategy that I like is when we have two fractions that are one away or maybe two away from being the entire whole piece. So 5/6 is almost 6/6. 7/8 is almost 8/8. And I know if I had that one last piece, I would have a whole. Well, if I think about these fractions and think about the part that's missing, this piece that's missing is going to be a little bit bigger, 1/6, than this piece that's missing, 1/8. So if I think about it in opposites, the bigger missing piece means that this fraction is smaller than this fraction. So look at how much is missing to determine which of the fractions here is larger. The last way that we talk about is making common denominators. This is the old-fashioned traditional way of figuring out which denominator you can turn these into. 4 and 3 can both be turned into 12ths. So I can make equivalent fractions of 3/4 equal to 9/12, 2/3 equal to 8/12. Compare then 9/12 to 8/12. 9/12 is larger. This way will always work, but it does involve lots of extra math than any of the other ways that are here. And you don't always understand what the actual size and value of the fractions are when you just look at numbers and multiply them together. So in this example, see if you can look back at possibilities 1, 2, 3, 4, or 5. Are there any other strategies you could use to figure out what these are, which one's larger and which one's smaller without doing this step? So that's my challenge to leave you with. Okay, good luck comparing fractions.